Okay, let's do this. Can everybody hear me? Can everybody see me? Can anyone confirm? That would be awesome. Thank you, Oscar, as always. Oscar is a fellow colleague from Mexico, and he is always the first one to let me know that I'm audible. Oscar, did I press record this time? I think I did. Excellent. So, welcome to another Meyer Sound webinar. Let's do some housekeeping first, which means that I'm going to share my screen. And there we go. Okay. So, today we're going to talk about Cine-Studio. After all the webinars that we've seen so far are in the Precision Toolset framework, and Cine-Studio plays a big part in that framework as well. And that means that today we will have a special guest lecture. Alex Harbaugh. I'm going to introduce him again later during today's webinars. So today's all about Cine-Studio, post-production, studio cinema, domestic audio. Very excited about this. But before we get started, let's talk a little bit about Zoom, which is the platform that we're using for these webinars. And that means that in front of you, you are expected to have a window not unlike the one you see over here. If you want to see who else is joining you on the call, please click on the Participants button, in which case a window pops up on the right side showing your fellow attendees. We encourage you to ask questions. I will be there to moderate today's questions, but in order to do so, please make use of the Raise Hand feature. Whenever you click Raise Hand, a blue hand icon pops up in the corner of my eye telling me that you're about to ask a question. And in order to ask that question, we encourage you to make use of the chat feature. So by clicking on the chat balloon, the chat icon in the bottom of your window, the right side window, the pane splits in half and a second window shows up. And at the bottom of that window, you can enter a message and address the nation. Or if you happen to see a fellow colleague, a family member, or a friend, you can also enter a message and address that person in private. For those that are joining us, in the Meyer Sound Facebook group, the Meyer Sound user community, where we're currently streaming live, welcome to you as well. That are joining us over there. It counts currently over 8,600 members and rising, so we're happy to have you as an audience as well. As I said earlier during the introduction, this is another webinar in the within the framework that we've come to call the Precision Toolset, which is our turnkey solution for system design, control, and monitoring, as well as deployment of this system and distribution, and so on and so forth. And cinema, domestic audio, post-production also plays an essential role within that framework, and we use those very same tools for those applications as we're about to discover. And that means that without further ado, I'm very honored to introduce you to today's guest lecturer, which is Alex Harbaugh of Design Services. And that means that I'm going to stop sharing, and hopefully we have connection with Alex. Alex, how are we doing?
Can you hear me all right?
Excellent. So I can hear you, I can see you, and that means that I will refrain from talking any further and take it away.
All right, give me 1 sec to organize my windows. I will share my screen.
So we can see your screen.
You got the webinar?
Yep, we can see the screen. Awesome.
Excellent. Thank you, Milad. Yeah, so I'm Alex Harbaugh. I've been with Meyer for 5 years. I'm in the technical support department. I specialize in designs using Map XT and soon to be Map 3D. I also do calibrations and general, technical support, whatever's needed. So today, yeah, we're going to talk about a few different case studies for some Cine-Studio applications that my department has worked on in the last few years. We're going to cover three kind of main areas of cinema, ranging from professional with the studio and post-production to the private with residential home theater systems, and to the public with exhibition systems for ticket-paying audiences to go see their favorite movies. So without further ado, let's get into the stuff. Just to say it, I won't be specifically concentrating on specific products, but more the applications of those products and how we can provide solutions to, you know, help translate the intent of the content creators to be translated, you know, accurately to the audiences.
And that perfectly fits in our case study format, so applications are welcome. Much appreciated.
Yep, definitely gonna be talking a lot about products, but it's gonna be more systems of products. So let's get going into Studio and Post. All right. So this first photo is of the Fox scoring stage, which is a pretty big deal in the movie industry. And you can see above above that window they have an LCR blue horn system. And I thought this was interesting in that due to that window, they put the low frequency units above the blue horns and inverted the whole system. But I just wanted to show that picture because that one's kind of fun. Okay, so there's two kind of different formats of post-production rooms. There's dubbing stages and small mix suites, and I'll show you some images from both and kind of define what those are, and then we'll talk about some tools that are available, and we'll do a case study of a small mix suite. So dubbing stages are, if you watch a behind the scenes on any like DVD or something, you might see the director in a theater with a bunch of, you know, mixing consoles, but it won't look like your normal theater. It's probably a dubbing stage, which is where all the pieces of a movie come together and, you know, they are assembled into what the final product will be. So that's where they review all of that content, make the decisions, and they want that environment to be as close to an actual exhibition cinema as they can. So as you can see on these photos to the right, you know, there's different rows of seating. You have the operator at the console, the row behind it might be the director and producers, and then oftentimes there'll be couches in the back too. So what we have to think about of this these types of rooms is that we're not just aiming it at a single person. Definitely the person operating the console is probably the most important decision maker in terms of twisting knobs and stuff. But we have to kind of approach these as close to exhibition as we can. And in fact, we need to build additional SPL headroom into both this and the small mix suite type rooms, primarily because where the decisions get made, they need to get deeper into those mixes. So they listen to that louder than you typically would to hear those crossfades and all the little editing decisions that if you did turn it up crazy loud, you wouldn't hear, you know, cut off fades and stuff like that. So typically we design these rooms with a full Atmos theatrical configuration, and essentially with additional SPL headroom. So I'm not gonna spend a ton of time on this because it, you know, it kind of ties into the exhibition cinema that we'll talk about third. But the small mix suites are a little different. Here we have Bear's Lab at our factory. Once again, blue horns, and this room is interesting because it actually has a constellation system as well, and Atmos in this room. So this room, these types of rooms are specifically usually a single user, maybe two, but one seating position usually that we're aiming everything at. They need the additional SPL headroom that I mentioned. But one of the challenges is translating what decisions you make in a small room and having that accurately translated back to the big room. So one thing I don't think a lot of people realized about the history of the AMI speaker, which is our product, our studio monitor product right now that we've kind of targeted at the cinema post-production world, also music, was that we got the request that we wanted a small near-field studio monitor to accurately translate the SPL and headroom of a large Acheron screen channel behind a projection screen, 50 feet or so. All that adds up to a near-field monitor, so you have some air attenuation, that distance of SPL attenuation as well. That was the primary goal for the AMI, was to build a product that can translate from the small to the large room. And so far, there's been some pretty good feedback on that. So with these smaller rooms, almost all the time, they're smaller than the minimum of Dolby exhibition room sizes. You know, it just doesn't fit into their calculator, which we'll look at next actually. So we're seeing a trend in a lot of these small mix rooms to get Atmos home entertainment. That's the Atmos HE, which has, you know, fewer side surrounds, but Dolby has made a lot of tools to help translate those configurations to larger. And on the loudspeaker side, that's what we're also working towards, of getting small speakers to translate to large speakers accurately. I mentioned the room design tool. This is from Dolby. This isn't something that Meyer makes, but it's something that we use on nearly every cinema project, especially ones that deal with Atmos. So what these are Excel documents that you enter. Can you guys see my mouse? I'm not sure. I can't even see my mouse right now. Oopsie. Anyway, at the top, you'll see you can enter the dimensions of a room. And through that dimensions of the room, the calculator determines where the critical listening spot is, which you can also define with that mixed position field. And then it's triangulating the distance from where Dolby recommends all these loudspeakers be placed, which is on the right, and the resulting SPL from that distance to determine whether it will be a pass-fail of the SPL targets that they have. In the center of the top, you can see there's a calibration level. 79 dB is the target for the Atmos HE DART. And you can see with the system that I've entered here, I'm actually exceeding that by 3 dB with that 82. I'm still hitting greens and yellows. But as we move down, you can see there's drop downs for, you can see it says Meyer Designer and Meyer Sound X400C and Meyer UP4 Slim. That's where you'll select your product. Oh, thank you, Millie. That's where you'll select products, and to the right, those green and yellow fields are the kind of pass-fail indicators. If it was red, you would know you need a larger or more powerful loudspeaker to meet those SPL targets. So I don't want to spend too much time on this one. It's something you'd have to get from Dolby. We can't provide it to everybody, but it's kind of their certification process for Atmos post-production environments, specifically on this one. One thing we've come out within, I believe, the last year is new input cards for the AMI sub, which is the companion subwoofer, which is pretty cool that it allows base management of multi-channel systems. So you can quickly deploy a 2.1 AMI system just by plugging in a stereo feed, and that subwoofer will base manage those signals to both the two AMI subs, or the AMI and the sub. So that's it doesn't require an external Galaxy, and we have 2.1 and 7.1 versions of that. So that's something that if you're putting together a studio, it can save a bunch of money not having a processor on that one, or if you need to move it around a lot, that can be very helpful. Cool. So let's move into our first case study. This is a small mix room that had a few challenges and went through a few different iterations in the design process. It's still under construction. The only actual current photos I could find are of studs still. So unfortunately, I don't have any finished photos on this one, but it was a really fun project to go back and forth and handle some of the interesting parts of this room. The first thing you probably jumps out at you is this column right behind the seat. It kind of forces that mix position to be nearer to the monitors than you typically probably look for. So those blue horns are pretty much in a near field configuration, which is pretty cool, I think. But over to the right, you can see there's a side surround loudspeaker on the wall that's very large and pretty close to the listener. Originally, this system had been requested to have those large surrounds, and we were looking at larger HMS 12, I believe, loudspeakers, which was tons of headroom that they probably wouldn't ever use. So through some different design options, we came about to the UP4 Slim, which is quite different than the HMS 12 products in terms of size and SPL output. But it checked all the boxes, and it got us to where we needed. It has a Galaxy and an MPS 48 for all the loudspeaker power supplies, but let's look at some map predictions. So that that Dolby Atmos room design tool I showed you was actually for this room. So let me just skip back to there. They have the designer, which is what the Blue Horn is based on. So we knew the SPL was good for the designer. They have two X400s and those UP4 Slims. You can see the rear surround one, the yellow one, was the only one we were a little nervous about, but I'm totally comfortable that it will be exactly what they need. So let's get back to the map predictions. So a little different than PA design is the workflow of how we work with cinema and the different kind of certifications and targets that has compared to PA, which is a little more open in terms of what you might look for from background music to an EDM festival, for example. With cinema, we have pretty well-defined targets of SPL, and those calculators that Dolby can provide and other tools that you can use can easily get you to picking the right products, putting them in the right places, which is oftentimes the bigger challenges of PA. And you get into the more integration side of things, and we also use MapXT to verify that SPL to make sure it's going to give them what we expect as well, because we have our own cinema design standards at Meyer that were based on the SMPTE 202 spec, and we just want everything to align, and so far it's been perfectly in alignment pretty much between the room design tool and what we predict in map. So what I'm showing here is a plan view on the left and a section view on the right, just a 4K prediction of a screen channel. What I used this map file to was really communicate where the loudspeaker positions can go against the architecture, and to verify internally the SPL is what we expect. And as you can imagine, 5 feet from Blue Horns, it's gonna be loud enough. But also, you want to get into the coverage to make sure you're not missing some important areas in interesting rooms. This one's pretty straightforward. So one seat down the barrel, it's all good. But just to talk a little more about this one, it's an Atmos HE configuration. It's a 714 system. So we have our side surrounds on the top and bottom in the middle of that plan view. We have rear surrounds on the right side. And then the square of horizontal loudspeakers that you see clustered around the microphone are the top surrounds. And you can kind of translate those positions to the section view and get a maybe a better idea of their aiming and position to the mixer. It's kind of interesting how Dolby has defined their overhead channels for Atmos HE specifically, when they want a fairly regular, even spacing of those top surrounds above the primary listening spot. My first instinct when I looked at this room was to put that first front top surround immediately above the mixer and the back top surrounds farther back in the room. But having to play with Dolby standards, that this is what the spec defines. So that's what we went with. So it would be accurately translated through all the different pieces of that signal chain. Cool. So talking about Atmos Home HE kind of leads us into the residential cinema side of things. Those small mix rooms actually tend to be very close to residential cinema. But residential cinema is kind of a huge field, because some of the first residences we were doing were actual content creators, directors, producers, who had seen the stuff in the post-production facilities and said, I want that at my house. I want to do my work at home with the same stuff. A lot of times we've been doing home residences that have full theatrical Atmos systems in them, with Dolby CP850s and 30 loudspeakers around the room. We also do the small rooms where it's 5 speakers, it's casual movie watching, but they want extremely high quality sound. So we're going to concentrate mainly on the smaller applications in this case. But one thing I wanted to mention was I've talked about SPL headroom and the SMPTE defined SPL targets that kind of have shaped exhibition cinema to become more homogeneous and have a similar viewing experience between different cinema has changed and everything. Home entertainment is a little bit more of a Wild West in terms of nobody's going to show up at your house with an SPL meter and say, nope, you didn't hit the SPL, you may not operate this sound system, kind of thing, right? So we can choose, and it's usually a conversation between the end user and the installer and us. If we want to pick a product that might not meet the SPL headroom we'd be aiming for in exhibition or post, which is our starting point. Sometimes that's acceptable for home. So that's just one thing to know, is it's the most wide open field of cinema in terms of what's acceptable. The expectations, range widely from private to professional. And a few things I'm going to talk about the residential cinema field is the different integration options that come up with residences, because a lot of times those places they want to recess speakers or do interesting or challenging things that lead to some interesting discussions, more so than often in post-production. So we'll talk about that. We'll talk about screen channels, and specifically for the home, for like LCD and OLED TVs, what to do with screen channels when you can't put them behind a projection screen, as well as the overhead challenges in residences and some things we've seen pop up. I was talking about last week, actually. So, and then we'll do a case study. So let's move forward. So one thing that Meyer offers, and I mentioned, is that we offer design assistance in addition to technical support. So one thing I see as a big value for that service of design assistance is knowing our products. We don't expect every installer to know our products in and out as well as we do. It's always nice when they do, but I'm at the factory and dealing with speakers all day and only talking about Meyer speakers. So I'm happy to help and offer that knowledge to help you succeed in integrating loudspeakers for all sorts of things. But yeah, we use acoustic modeling in MapXT and 3D to show our work and verify that it's going to do what we expect. And then we offer calibration services as well. So once that system's installed, we can come up and tune that system, make it sound the best can be for the room. So just some examples of some things that I've seen our department offer that kind of I saw that they were eye openers for the person I was talking to, and I just made a mental note that it's like, yeah, they might not have thought of that if I wouldn't have been mentioning different things back and forth just to solve problems or have them think outside the box kind of stuff. So our intelligent DC line is something that a lot of people know about, but a lot of times it's not in the front of their head. So just to say, intelligent DC is remotely powered loudspeakers. They're still active, the amplifier is still in the loudspeaker, but what is nice about that is it's low voltage, 48 volts DC. So specifically, an electrician doesn't need to be involved in running that cable. Typically, I can't speak for all codes and all regions and everything, but it definitely opens up more options for installers to place loudspeakers in places they don't need to run AC mains to. And just one cable provides power and balanced audio to that amplifier. So it offers a lot of options for integrating speakers in places that you might not have thought you could get power and signal to, or stuff like that. In residences, oftentimes there will be a reduced space between the projection screen and the back wall. So that top image that I'm showing to the right is comparing an Acheron Designer to an HMS 12. Those should offer definitely adequate SPL for a small home cinema, but you can just tell the depth difference that we gain by going to the HMS. When we mention something like that, it comes with a few different things of like, if you use that HMS, you're going to want to base manage because they don't have quite the frequency response of an Acheron Designer, for example. But it can, provide some wins or architectural points, that kind of stuff. So yeah, thank you, Merlin. The red is the HMS 12 and the blue is the Acheron Designer in that top image. Okay, so moving on to the lower image, one thing that we've done a lot that a lot of people don't consider is using PA products for surround or any part of a cinema system that you might want a lower profile, for example. So in this lower image, I'm comparing an HMS-10 to a UPJ. The UPJ is the largest point source loudspeaker we offer in intelligent DC. I guess that's not including the HMS-12. But just this image kind of shows the point that it's about half of the height from the ceiling to the end of the loudspeaker, comparing the red UPJ to the blue HMS-10 right there. And you get the same aiming with that center line shown. My chat's flashing. Let me see if I can find my cursor. Oopsie. All right. Merlin, can you let me know if there's chat questions and things?
From what I can tell, there are no questions. I just mentioned that there is a webinar by Rahul Samuel on Intelligent DC on our Thinking Sound YouTube channel, just as a referral.
Great. Cool. I think I missed the last one. All right, so yeah, the last point on this slide was just we offer, different levels of help for recessing or hiding loudspeakers as well, ranging all the way from just general advice of, hey, don't do that, that's not going to do what you think it's going to do, all the way to, fabric testing for acoustically transparent fabric. A lot of times it might not do what the manufacturer tells you to, so we will put it, through its paces and test its on and off axis, frequency response and transmission loss. And there's some things that were surprising to us, and we're happy to help along the way of making sure, if you do need to hide your loudspeakers, to make sure that their performance, the coverage, the frequency response comes out as well as it can with those challenges.
Right, only transparent steel is allowed.
Or glass. I actually had an architect ask about glass. Cool. So screen channels and emissive displays. We're going to talk about small emissive displays like LCD and OLED monitors. And actually, this picture is of my living room. I redid my home cinema living room system last year, and I used UP4 Slims for my LCR. And you can see, oftentimes, especially with soundbars, people are putting screen channels below the screen. And that's not something I typically recommend, primarily for occlusion. If someone walks in front of that, it's going to be very easy to block that sound if it's low. If it's high up, the occlusion will be better, the coverage will be better. And also, I've noticed in watching movies and things, most of the time, the source of where that sound on the image is coming from is from the middle to the top part of the screen. So just imaging wise, center channels above the top center of the screen are what I almost always typically recommend. And then the left and right, you're going to have to put them to the sides. Just like behind a projection screen, we want to get the acoustic center of those loudspeakers as close to the 2/3 point of the image as we can, in the height specifically. And I was a little disappointed that the mount put my TV a little lower than I expected, as you can imagine. And I've also since mounted my acoustic panels. All right, so we get the question a lot of using Ashby top surround loudspeakers for their, architectural, recessed can advantage that people like to not see speakers hanging down from the ceiling sometimes. But one thing I wanted to bring up was when you place a speaker in the ceiling, it's going to be firing straight down, and you don't have a lot of options to angle that unless you modify the architecture or do something interesting inside where that speaker's residing. So I had actually prepared these images last week for a project where they were asking about this. And what I had designed with the UP4 Slims, you can see that center line on the top image is aimed towards that microphone where the primary listening position is. That was all looking good. And then they wanted to switch to Ashby, so I prepared this image of saying, if we change to Ashby, we're going to need to relook at how those loudspeakers are laid out because if we just pop them in those same positions, that position's never going to hear those front speakers, because it's effectively about 15 dB down in that high frequency band gain. You can kind of compare the colors of orange versus almost completely out of the yellow on the top and bottom to kind of see that difference in coverage and how that's not going to get heard by those people. And those colors are 3 decibels per color in an octave around 4 kilohertz, just to say that. And then the other difference between the UP4 Slim and Ashby also is about 4 decibels in headroom, with the UP4 Slim being louder. So I saw my role in this to say, don't use the Ashby, but here's what's going to happen if we do what we had been planning and just swap the product out. If we do want to change that, let's relook at the location of that so that the listener can hear all of those top surrounds. If a helicopter swirls and pans around there, they won't get an on-off sensation of having that high frequency come in and out. They will be in the coverage of all the loudspeakers and just hear the panning as opposed to the speaker coverage coming on and off. Cool. So we have a case study. This is a residence that has a 916 Atmos HE configuration. Once again, we have blue horn screen channels. I really like this image because the installer did some cool lighting effects, because these are all actually behind fabric. But when the owner wants to show off the speakers, they have some cool lighting features to do that. So this project, I have the products in there, but let's talk about kind of the design process of this one, because this one was a little interesting. So especially with residences, we often are just offering design reviews and advice, because people can pick products and put them in their rooms all they want. They don't have to involve us. We're happy to offer assistance whenever we can. So when this project came to us, it was already pretty much the way you see it. There's been some minor changes to it, but there wasn't anything that we said, no, do this instead, don't do that. This was all from a good place, and we helped refine it to just get it to the best it could be. So there are 2 seating rows, as you can see on the left of that image. So we knew we needed to cover some horizontal with the side surrounds. So I'll show you some map predictions that show our original design intent with that. In the process of finishing the design and putting it into the room, some of the functionalities changed, and we'll talk about that and how that ended up into the photo you see. I guess right there you can see at the bottom, but we'll rewind back to this and explain what happened. Not that it's bad, it's just changed the design, and that's totally fine. So here's some map predictions from our original design about 2 years ago. I mentioned that they have 2 rows of seating, and unfortunately that's not shown in these architectural drawings we got, but we were aware of that. So the one thing I wanted to point out on the plan view, I guess it's on the section view as well, is if you look at the sidewalls on the top and bottom of the lower image there, you'll see 3 loudspeakers. And the point to make on this is that those 3 loudspeakers are only playing 2 channels of cinema content. The left speaker on both the top and bottom are what we would call the front wide. That gets its own discrete channel, but the 2 to the right of that are actually playing the same content. That is the side surround channel. And since that is the closest to those listeners, if we only had one of them and we weren't really careful where we put that, the potential for only 1 row of people to hear that speaker at the level they needed to was going to happen. So we had recommended, 2 side surround speakers per side for that coverage, as I'm showing here on the lower image. On the top image, I'm showing the coverage of 1 top round, and it kind of demonstrates the aiming that helps that loudspeaker's dispersion get to that listener. So that was, the design services role of that was to say, hey, this will get you the 916 system that we can see fitting in the architecture well, and gave it back to Tim Rooney at All Around Technologies, and he continued the conversations with the client and with our technical support side of things. And when I was reviewing this project, I saw the photos and I had prepared these images and I was like, wait, what's that back surround? It's an HMS5. I didn't know about that. What happened? Why is that one there? And the answer was pretty interesting. Was that the owner decided that he wanted a point source 5.1 system for his super audio CDs. So that speaker is effectively a discrete channel for only 5.1 listening, separate from, say you put in a Dolby Atmos Blu-ray, it's going to go to the 916 EP4 Slim system. So there's some interesting routing and configuration with this system that it kind of covers so many bases. It just made me happy that they got what they wanted. And, you know, the same location worked for that point source side rear surround, that HMS5. You can kind of see it's mounted sideways. And that's one thing I hadn't made a slide on or anything, but just to mention it, the HMS series has a built-in 15-degree down tilt. So when they mounted that sideways, that 15 degrees aimed that speaker into the room towards that primary listening position. And it looks like it's aiming, you know, from this photo, we're kind of looking right down the barrel of the horn. So kind of got it to where it needed to be. So that was kind of cool to see how that project ended up. I hadn't followed up on that one. So I'm glad that worked out well. All right, we are to exhibition and large scale. On the left, we have the Directors Guild of America Theater. They have all of our stuff in there. You can see it's a full Dolby Atmos theatrical system with lots of side surrounds and top surrounds. Those are HMS 12s, and I believe the very front top surround and side surrounds are HMS 15 because they need to throw a little farther. So we want one speaker up. They also have a CAL center channel for a PA in that room. All right, so Meyer Sound, we've been doing spatial systems for a long time, and I don't want to toot the horn too much, but Space Map, we've been using that in CERC. We've been moving sound around arrays of speakers for a long time, and that translated into Constellation and is now moving into Space Map Go with iPads. But it's something we've had a lot of familiarity with on how to move sound around a room and what loudspeaker designs and configurations will best support that kind of output panning, essentially. So when it came to cinema having that, we were really excited because we could bring that knowledge to the cinema systems, and it's been really interesting working with Dolby very closely on cinema systems and learning their approaches and the tools that they can provide. And when we got into the cinema system market, we had, you know, just defined some internal cinema standards of specifically SPL. And as I mentioned, cinema has the, I guess, luxury of being fairly homogeneous in the SPL targets that a long time ago SMPTE defined through their 202 spec. And we used our measurement methods to reverse engineer SPL targets within MAP that that follow the SPL targets. And that was where we started with 7.1 systems before Dolby Atmos came around. And thankfully, Atmos and the other formats have been pretty compliant with those same SPL targets. So all we've really changed on our cinema design process is adding more surrounds and following the guidelines of those different formats like Dolby Atmos or Oro or DTSX or IMAX. So we looked at the Dolby Audio room design tool for HE systems for home. And there's also a theatrical version of that, which is a lot bigger. And let me show you a screenshot of that. There's more speakers, there's more places to pick. You can see on the top right, since cinemas for the most part are rectangular prisms in 3D, you can do a lot of the design in the spreadsheets, just like the HE, where you're just entering dimensions, it's calculating where that reference listening position should be, and doing the triangulation to find out the distance versus the SPL of a loudspeaker and what the resulting SPL will be at that listening position. So if you remember that earlier Dart, this just has more cells, but we still have the column of green that this system that I've entered meets the SPL criteria for a theatrical Atmos system. And one other thing I wanted to say, in both Darts, you are able to enter custom products. So working with Dolby on making this room design tool, we got them all of our cinema products, as well as a few of our PA products. But like I mentioned, we can think of interesting ways to solve problems or challenges with PA productions. So there's times when you might need to be complying with the Dolby Atmos spec and using this room design tool, but you might want to use a Ultra X40 or a USW 210P for the surround bass management, but that's not in the calculator. So there's an extra equipment entry tab where you can enter the speaker model and the coverage angles, and most importantly, the max SPL. And then that option will show up on that drop-down list where you're picking the speakers in the main entry sheet. And I've included a data sheet and the specs where we found those SPL numbers that I entered into this sheet. So it's really just from the data sheet. There's no secret info that's allowing me to use those custom products in this Dart. So just that's something that some people don't know, and I just wanted to let them know that just because that product is not in the Dart does not mean it's not approved for Atmos theatrical or anything. That's not what that list of speakers is. It's just what Dolby has measured and can include in their calculator. But thankfully, they've let us. They gave them the option for people to enter their own products that they might want to use. All right. So once we move up to large scale, some of the challenges of bigger rooms that weren't made for cinema, and just in general, providing good low distortion sound to a large audience of people, which is what Meyer's always specialized in. So we were happy to bring that knowledge to cinema, and it's been really interesting and rewarding to help put large scale cinemas together. And I'm going to show a couple interesting quick case studies that can cover some solutions that I've seen as a value of including our design department in talking about these. So one of the biggest challenges that I've seen moving to spatial cinema systems like Dolby Atmos is when you don't have a perfectly rectangular room and single seating plane like a traditional cinema has. A lot of rooms have balconies, and that's the one I wanted to talk about here was how you can make a system translate panning to multiple levels specifically. And this has all been, coordinated and collaborated on with Dolby on multiple projects. So that's one thing that we've had success with in these challenging rooms and have been very collaborative in those solutions. So this space is Cinerama. It's in Seattle. It has one of those super wide screens. They use 3 projectors to do special events with and stuff. But this room does have a balcony. And I'm going to show you a few different views and layers of speakers turned on to help communicate the kind of complex system that had to be put together to deal with these architectural challenges and still translate all the effects for all the seats. So on the top of this image, you'll see a section view of the architectural drawings. And below I have a photograph, but in the next few slides that will turn into a plan view. And we're gonna flip between the main floor's plan view and then a plan view of just the balcony. And it should be pretty clear, but I'll call it out when we get there. But let's move on to the first slide. So this room is double interesting in that it has a balcony, but also that projection booth juts into the room. So the rear wall is not a continuous plane. It actually jumps about 15 feet into the audience. So the first thing to comment on that is if you follow the side walls to the rear wall, you will see those rear surrounds follow that booth as well. what I wanted to specifically point out about that is if this were a 5.1 or a 7.1 system, those speakers would all be playing the same channel, and traditionally they might get one output from a processor because you might treat that as an array of speakers and only need one EQ for that. But in this case, if this were only a 5.1 system, due to those different conditions that those are in, specifically the distance to the listener, as well as the distance offset of the physical loudspeakers, we would want at least two channels to deal with time alignment as well as equalization of those essentially subsystems of one channel of cinema content. But since this is an Atmos system, those are all getting discrete channels, and a sound can be panned smoothly between all those. But that was the first thing to mention, was that this one had a weird booth that juts out, and we can roll with that. It just takes a little more processing and thought put into that. And additionally, when that seating on the main level rakes up, the balcony brings that ceiling much lower. So I'm not going to talk about top surrounds until the next few slides, but one thing that did give us was, number one, the challenge of a very low ceiling in the back compared to the rest of the room, and how low that made those rear surrounds be compared to where we might ideally put them, which would be in a linear line with the front side surrounds. We'd want that about 4 or 5 feet higher than where they're shown. So when we moved those lower, it kind of became a challenge. And okay, if we try to shoot all the way to the front row, we're going to smoke those back rows. They are just going to they're not going to have a good time if something hot comes out of those speakers. So what we would have normally picked product-wise, we downsized to only cover under the balcony. And it might need some highlight on this, but if you look at the section view of the balcony face, we chose the larger loudspeaker to be mounted on the balcony face to basically pick up that signal and shoot it farther from a better position to get to those front rows. And once again, those would take multiple output channels for those different conditions to play the same signal and delay them and equalize them to be seen as one system. But that's one thing to mention. And on the next slide, where we go up to the balcony view on the lower image, I hope that's clear. We also need rear surrounds for the top balcony. So if you think about one channel, even in Dolby Atmos, one channel of a back surround, say rear or right, so that actually has 3 speakers playing that single channel. So what you input into likely a Galaxy for our system, you would need 3 outputs with different processing potentially to not get to maximize the potential for that system to be as good as it can be. And then just to kind of help visualize that, I included a 4K prediction of those 3 speakers. These would be playing the same signal, I guess not on the bottom view. That would be like the rear surround in a 7.1 system. But it kind of conveys the idea on that top image. And then a similar challenge comes up with the balcony and the top surrounds. So in a kind of typical Atmos system, you'd have 2 rows of top surround loudspeakers. And what do you do when you get to the balcony and there's 2 levels and you have 2 sets of loudspeakers? And one interesting thing we did here is we used, since these are so close to the listener, we used those EP4 XP, I believe was the product at the time. But we used them in clusters, and I should have put a map prediction of this, but I'll try to do it with my hands, in that they're kind of aimed in a triangular splay to maximize trying to get 180 degrees of coverage essentially out of that 100-degree dispersion with 2 loudspeakers. So that was what we worked on Dolby with, of kind of bringing the top surrounds closer, but making them wider in dispersion to cover as many people as they could, so that when some object is panned from the front to the rear, those levels are all similar, and everyone is in the coverage of as many loudspeakers as they can be essentially. And then that's the top balcony. So Oh, and the other part to mention is we had to space the lower top surrounds wider due to that booth, so it wouldn't just be slamming into, half the coverage slamming into a wall. Cool. So that was Cinerama. And then the last project that I really enjoyed working on and was very rewarding to see come to fruition is was the Apocalypse Now Final Cut premiere at the Beacon Theater for the Tribeca Film Festival. That was one thing I saw come in, and I was like, I gotta do that one. So it was really fun to work on, and had some really interesting challenges because it wasn't in a exhibition cinema space. It was in a performing arts center hall with a very tall and deep balcony that extended very far into the room. It had a smaller first level balcony below that and a very deep under balcony for the main level. So it quickly became clear that this is a farther throw than we would typically look at in an exhibition cinema. And there's definitely a limit to getting the SPL that is, defined in SMPTE and our cinema design standards with even our largest cinema products. So this became essentially kind of a hybrid, system with line arrays for the screen channels and other PA products for the low frequency. And what, line arrays really offer some real great advantages. They have high SPL, they're modular. So as you can see, I've articulated this system's splay angles to put a nice little high frequency beam up the balcony, but not slam the balcony face, and get another beam that's not clustered as tightly getting that first balcony, and then another pinky finger shooting under the balcony. And that integration of this system is so much tighter and potential for missing where you're trying to get the sound to, right? If a degree is wrong on the top grid, that could be all aimed 4 degrees too tall and completely miss everybody, or completely smoke the front row of the balcony and have people running out of the room. So it takes a lot more care in the design, as well as the communication of that design to the installers or whatever crew is putting that up. And this film festival was an interesting example in the challenge of that, because after a film screening, they'll have either a discussion or a musical performance on the same stage, and everything needs to fly out in a very short amount of time. It was like something like 10 or 15 minutes. All this stuff had to go away and have a clean stage, as I understand it. So that was challenging, but line arrays, you can fly them out. They're already hanging. So in this one, I had kind of a unique opportunity with a line array design, in that typically I could not put line arrays this low, especially on stage. It's where the band would be, right? So this was a fun opportunity to get to say, this array will work great if you hang it low, basically 4 feet off the ground, essentially a super tall ground stack, but hanging. And it's got more to do with my hand on the video. It's got more of a back splay up. You can kind of see from that prediction the curvature of that array. So you're actually hanging it from the front point. It's hard to do with my hands, but it's kind of a atypical line array splay. But from the reports, it worked out extremely well. And the other thing to mention on line array products, if we're doing them for cinema and to be compliant with all the standards, line array products as screen channels don't extend low like an Asheron might. So that's when we need base management, and we would fly subwoofers next to these line array products or on top to extend that channel's low frequency extension, because we want to have that as a discrete base management loudspeaker system, as opposed to just putting it into the LFE. Because depending on the mix, if the same signal goes to the screen channels and the LFE, that has the chance of being canceled out before it ever hits a loudspeaker electrically. So that's why we didn't want to do that. And this one also had another really, really interesting and exciting application of our very low frequency control product. So this loudspeaker or subwoofer is based around the 1100 LFC, which was our big boy arena rock subwoofer. And we took that product, kind of design, and specially tuned it for a special project, to go very, very low, below human hearing, effectively simulating kind of extreme events or natural phenomenon. So that one goes down to 12 hertz, and it's a very low frequency extension to normal subs. So since it's below human hearing, one thing in applications that we found that's pretty important for the success of this specific product is structural coupling. Because once it's out of your hearing range, you're really relying on the feeling of your body movement. And if the ground is moving with that, it's a narrow frequency range compared to a full range PA speaker. That structural coupling really helps transmit, the energy and convey the emotion of the very low frequency stuff. So for Apocalypse Now, all the napalm explosions and things, were really getting that very low frequency content. And for the final cut, they had that same VLFC product in their small mix studio to get the content made for that low frequency range. So if we look at the lower image, that is a plan view of the Beacon Theater. And to talk about the subwoofer configuration for this one, it was a fun chance for me to apply pretty typical PA subwoofer applications into a cinema context to try to maximize the deployment of the system, to specifically not energize the rear of the stage house, because that's not a factor in exhibition cinema. Is, your subwoofers are typically up against a back wall inside of some kind of cavity, but they don't have a large volume behind them that can cause acoustic issues. So one of my goals when I approached this space, thinking about their stage house behind the screen, is I wanted to get all the energy forward as much as I could. And what I ended up designing and recommending was a end fire configuration of a mix of 1100 LFCs and VLFCs. And what's pretty clear once I call it out, thank you, Ryan, is the 1100 LFCs, the normal subs are in the center. They are spaced about half the spacing of those VLFC rows, which are on the top and bottom, and that's because they're effectively playing half the frequency range. So that when we're trying to control that very low frequency to get that, those long wavelengths to move forward, we have to space that end fire array twice as far, is the kind of general spacing I've recommended, as you would a more standard subwoofer end fire arrangement. So that was just one thing that kind of was like, well, I'll do a double, and yep, that's like the math checks out kind of thing. So that worked out really well, and it was fun to review this with Ryan, actually. And above there in the photo, you can kind of see how that ended up looking in real life. Just a field of subs spaced interestingly, but it provided a very, very low frequency response. And there are 12 VLFCs in this configuration and 6 1100s.
Yes. Sorry for intruding.
Go ahead.
No, I just wanted to augment that, people that are interested in this particular configuration are also encouraged to watch the Roskilde 2019 on-demand webinar, because a similar solution was also used at the Apollo stage. So be sure to go to Thinking Sound and check out those webinars as well.
Thank you. Yeah, and that's my last slide, and I'm happy to chat about this all we got, but it kind of looks like it's 9:59, so
You did great, Alex. Thank you very much for taking us on a journey from the small domestic to the large exhibition spaces and everything in between, and showing the awesome value of having a design department, design assistance department. I think that really came across clearly. So much appreciated.
Happy to.
So let's see if we can take a peek at the chat and see whether there are any questions at this point that Alex or myself can answer.
Alrighty.
So earlier during this call, we had a question on the use of power conditioners, and we're looking into the answer to that question.
Yeah,
so
I would defer that likely to more technical engineers on
yeah,
on actual performance
exactly.
benefits
So
or
we're
wash it might be.
we're digging. Fellow colleague Miles, who's also on the call, is digging into that. Remains to be seen whether we can find that within the next couple of minutes. I had a question that I answered in the chat, which was, does map also show you the effects of the screen? To which I replied that for Cine-Studio products, we do show the effects of perforated and woven screens. So you can actually model that in MapXT. So somebody asks, and I take it, this is a question of Veen Garcia about the Coppola screening, whether absorption was added to the backstage.
Nothing that I'm aware of. Stage houses often will have lots of soft goods, curtains, borders flown, just waiting to be used, or sometimes they'll deploy them for acoustic purposes. I'm not sure, but I imagine there was some stuff doing some mid-frequency absorption back there just by being a stage house.
Alex, we actually, just to jump in here really quickly,
Yeah,
we dropped some really heavy drapes right behind the back of the line arrays.
I do remember seeing that. Yeah, kind of a main drape behind those line arrays.
And it appears that we have some clearance on some extra information on the use of intelligent DC with power conditioners. It's as we saw in the intelligent DC webinar, the power supplies are fed from AC power. So those can be used. Those can be powered from the same mains power as you would use for the remainder of the system. Okay.
Kent Clayson joined too. Hi, Kent.
Sorry?
One of my buddies from Kansas has joined. I was saying hi to Kent. So.
Okay. Excellent. So that means that as the chat is cooling down, I will share my screen once more with some remaining household notes and announcements. And first and foremost, I want to thank Alex. Can you see my screen?
Yeah, I got it.
Okay, I want to thank Alex once again of Design Services for doing an awesome job on taking us through several case studies. This Friday, as part of the Cine-Studio week, we will have none other but our founder, John Meyer, and he will take us on a journey from Apocalypse Now, which basically ignited cinema for Meyer Sound, to the pinnacle where we are currently are with the Bluehorn system, and I'm very much looking forward to it. Please be advised that this is going to be a Zoom-only session, so we will not be streaming this particular webinar through Facebook Live, through the user community. So please join us on Zoom. The links are available in the announcements. And of course, today's webinar, including the other ones that came up during today's presentation, will also end up on YouTube on our Thinking Sound channel, including the one on Intelligent DC, which was brought up earlier today. So be sure to watch those. And that means thank you for being here. Thank you for enjoying another Meyer Sound webinar. Thank you, Alex. And it appears that there are no questions anymore, so all that's left to say is stay safe and please stay healthy, everyone. Bye-bye.
Thanks, everybody. Bye-bye.